So at this point, I'll hand over to Steve, and he'll take us through his presentation.
Okay, thanks, Stephen. Well, as I say, I'm Steve Hyde, and as Steve said, I've had a fairly long, I did have a fairly long career in the rail sector. Signalling and telecoms was the prime technology that I was involved with. I joined British Rail in 1972 at Guy Bridge in Ashton, and worked my way through various sectors of the S&T department. And in 1991, I took, well, I suppose I didn't think it was a brave step, but I was told I was making a big mistake in going into the private sector and getting involved with Metrolink. And I was lucky enough to be able to join in the setup period. So construction had already started, but there was a small team of us involved with the operating company trying to set things up. And I was lucky enough to be able to start with that. And I stayed with Metrolink right through the Greater Manchester Metro operation and Serco Metrolink. And eventually I left there in 2007 to go with Mott MacDonald in Altrincham Consulting, still on Metrolink, but also involved with Nottingham, Croydon, Midland Metro, and finally finished, well, really about 2015 after a bit of part-time work. So to tip into Metrolink itself, obviously Manchester had a problem for a long, long time with two rail networks that weren't really properly connected. There were connections, but they weren't ideal. It been in need of a cross-city rail link of some form, well, basically since the railways were brought into Manchester. At the time I started on British Rail, the big thing was the Pickvick, and I remember my boss, a divisional S&T engineer at Manchester, telling us all the new starters what a great thing for our careers this was going to be. And of course, it got dropped. A story that was going to be repeated over the years. The idea was to have a cross-city low-level tunnel with stations at Piccadilly low level, Princess Street, or various names for it, Whitworth, one in the Albert Square area, one at the bottom of Market Street under what is now the Arndale Centre. There's still rumour that the platform chambers were actually built. And then one coming where it came out at Victoria low level in the Long Millgate area. And that would have provided the ability to run services from the south side of Manchester through to places such as Bolton, Bury, from Hazel Grove, Alderley Edge, and places like that. As I say, sadly, it was dropped by the government in 1977 because it was going to cost too much. And at that point, things stalled a little bit, or they appeared to. But Greater Manchester PTE and British Rail and other bodies, local authorities, actually in the background were working on a rail strategy. And they looked at various options to try and get around the problem. Light rail became the front runner, and there were various options studied to create a link across the city and bring in some of the local rail lines. They looked again at tunnels, but they would have had the same problem with cost. So they went for the surface tramway, or as it was called then, LRT option, which formed the core of the network with three branches combining at Piccadilly Gardens. One coming from well, let's call it Central Station, because as near as damn it, that's what it is. One from Victoria and one from Piccadilly. By 1984, the proposals were being firmed up. 1987 saw a demonstration set up between BR, GMPTE, and some of the private engineering companies that were likely to be involved in the scheme. And Docklands, the Docklands Light Railway Unit 11 came up and operated on a short stretch of track between Hyde Road Junction and the west end of the line at near Reddish Depot. It was a project I actually managed to get involved in when I was on BR. The unit was temporarily fitted with a pantograph in place of the third rail shoe. Power was fed to it by means of a long feeder cable from the Hadfield line, 25 kV, to a class 303 EMU parked under a bridge on the Fairfield spur of the Hyde Road branch. And they needed a train driver and a tram driver to operate the thing. It was a very successful demonstration though, and it showed people what they might expect in terms of the vehicle layout. The photographs, top one is the delivery run passing through Hardwick Station, and then the unit on demonstration at Hyde Road. So GMPTE took a strategy on this project because it was going to be a massive project, and they set up a big publicity campaign describing what they foresaw the network would look like, what the trams might look like, and where they would be. It was a strategy which, unfortunately, some of the other systems didn't follow. Sheffield, in particular, had a big problem, a PR problem, because they didn't tell people exactly what to expect. GMPTE went hell for leather, if you like, in publicising what they were doing. Now, the slide isn't very big, I know, but it shows the tram network superimposed on the rail network. We've got, I can't read it in here, but there's the Bury line, the Oldham Loop, Altrincham, East Didsbury, one that never came off to Hadfield, and Marple and to Rose Hill, which obviously hasn't happened either. But the core of the network, Bury to Altrincham and into Piccadilly, and the future line out to East Didsbury and the Oldham Rochdale Loop, obviously have all actually happened. So the way this was going to be built and financed was going to be through the government dictated how it would be put together. And the procurement strategy meant that private sector involvement, similar in pattern to the Docklands Light Railway, which was almost complete at the time. And the contract was slightly different. It was unique. It was the design, build, operate and maintain contract. The tender process resulted in the contract being awarded to a consortium called the GMA Group, which was GEC Alstom, who were going to do all the electrical, the control and the rolling stock work. Molan Civil Engineering, they would do the track conversion of the rail lines and bridge works, because quite a lot of the bridges needed attention. AMEC, who would build the depot and the operations centre, and Greater Manchester Buses would bring in the operations experience. Interesting that technically none of those companies exist anymore. They've all either been swallowed up or disappeared completely. GMA formed an operations and maintenance company to handle the day-to-day running of the system, and the company was Greater Manchester Metrolink Limited. That's the company I worked for. They were awarded a 15-year operating concession. The revenue risk lay with them. The system was eventually defined as 26 stops, including the new city centre stops, and GMA as a group took the risk on saying we can operate that with 26 trams. It wasn't the PTE who specified the number of trams, they specified a service level, and the risk then sat with the operating company. Again, once the project started, the PR and publicity kicked off with regular newsletters being put out by both the Construction Consortium and Greater Manchester PTE. These are two of the early ones, almost like celebrating the award of the contract. And again, we can see the layout that was coming in, which was Bury through the city centre to Altrincham with the branch down to Piccadilly. They do show two lines, well, actually three lines on there for sort of future wishes, if you like, which was the Dumplington, which has happened eventually, just going to the Trafford Centre, the little branch into Salford Quays, and the Oldham Rochdale. As construction started and the diggers actually hit the streets, again, they went to town trying to, I suppose, explain what was going on, what people might expect. And there was actually a track laying ceremony on Long Millgate, just outside Victoria Station. These newsletters were quite regular. As I say, they're not all dated, unfortunately. The left-hand one is spring 1990, and in June 1991 we see the start of the Delta Junction being laid in the city centre. The Phase 1 network is a little bit better slide than the initial map. So we have, I mean, everybody I think is aware of what was built. All the stations on the Altrincham line, as far as Old Trafford, were converted for tram operation, and on the Bury line, all the stations right through to Victoria were handed over. And we then built a cross-city section coming out of Victoria Station, across Corporation Street, up Balloon Street, High Street, into Piccadilly Gardens, the branch to Piccadilly Station, and then out through St Peter's Square, up a new ramp alongside Central, and out along the old viaduct to through Cornbrook to pick up at Old Trafford. The Old Trafford on there is actually Trafford Bar, and Old Trafford is Warwick Road, as the old BR names for them. The future phases are shown again as Hadfield, Marple, Rose Hill and Marple, Oldham Rochdale, and we now go as far as Langworthy on the Salford Quays branch, but Dumplington seems to have disappeared. Oh, and we have the East Didsbury. GMPT had protected the South Manchester alignment of the old Midland Railway, and they'd actually had that protected, and any developments that were built around the Didsbury area were actually built up over it on concrete rafts, so that it wasn't lost. Right, city centre track lane. This was the most visible part of the project, obviously. And in 1990, as I say, there was a little ceremony on Long Millgate outside Victoria Station, where they laid well, it was 2 bits of rail welded to angle iron, I think, and it was just dropped in position on the concrete track slab. One of the things that did happen in the city was there was an awful lot of the old first generation tramway track found, and quite a bit of it actually found its way to Heaton Park, to the Heaton Park tramway, where some of it's been used. The biggest part of it actually came out of the cricket ground siding at Warwick Road. We also see the track being laid alongside the Midland Hotel on Lower Mosley Street. Again, there was a junction at the back of the hotel at Windmill Street, most of which was saved, thanks to Molan and my regular visits. Yes, we took delivery in March 1990 of a prototype, a mock-up really, of the Ferema T68 tram that was to be the Phase 1 fleet. This is shown on the day of its delivery. It resided in one of the arches off North Western Street under Piccadilly Station, well, under the approaches to Piccadilly Station. It was used to fine-tune the design, get comments from disability groups, operating staff, and various local dignitaries, and the design was modified. The mock-up now resides in the Greater Manchester Museum of Transport, behind Queen's Road Bus Depot, in its modified state. By 1991, things were coming together, although the project was delayed. the Bury line was under conversion. It closed in 2 stages, with trams beyond Crumpsall ceasing in, I think it was July, and 2 months later they ceased between Victoria and Crumpsall. And the old class, were the 504 EMUs, were dragged out through the depot yard here and off to their fate. In August, end of August 91, the first tram arrived. It had a rather eventful trip across from Italy, and it was a trip that was never to be repeated with the T68s. It came in one piece. I think it demolished a police car in, I think it was Southampton. A police car got too close to it on a roundabout and suffered the consequences. But the transport in one piece across Europe proved too difficult, and the rest came in 2 sections. I think there were 3 lorries for each, one for the 2 body sections and one for the 3 bogies, and then they had to be assembled on site. The branding had changed from the GMPTE orange, Sunglow orange and white, and this was the Metrolink aquamarine and grey, which was later to be revised. So the Phase 1 tram, with its exposed couplers and heavyweight railway style bogies, was unique to Manchester. The cost was about £750,000 a unit, which compared price-wise, compared very favourably with the Sheffield cars of 18 months to 2 years later, which were nearly £1.5 million a piece. But as one of the Italians said, yes, you were buying Fiats, they were buying BMWs. So even the Italians didn't seem to be that proud of the T68s. By September, the trackwork in the city centre was ready for gauging. Now, this is structure gauging to make sure that the tram doesn't take any poles out, doesn't hit the platforms, and basically will negotiate the alignment in the streets. This was done prior to the overhead going up, so the Metrolink diesel loco special purpose vehicle provided the motive power for it, and it did the whole of the Phase 1 city network, with the exception of A-Town Street to Piccadilly Undercroft, which wasn't ready at that time. We then moved into sort of system testing. This is a little bit different than what's happened in later systems. It was done in sections, Bury line first, then the city centre. It mirrored the opening, actually, then at the Altrincham line, and finally the branch to Piccadilly. We had to obviously prove all the electrical systems were safe, and then the first trams were allowed in, and that was about December, I think, December 91. And we had to prove that the trams could operate safely, they could operate the traffic lights, they could operate alongside the buses, because buses were the main vehicles that they shared the route with. There was no true street running in Manchester city centre in the sense that we see now, because even in that left-hand picture, that double unit is only operating on a tram-only section of track there. So there were some interesting tests took place. Obviously, we had to prove that double units were able to be operated, the power system was reliable. We had to be able to prove that on Balloon Street, which at the time was the steepest gradient on the system, that one tram could hold another unbraked tram without them rolling away, and that one tram could rescue an unpowered tram on that gradient. All these had to be demonstrated to Her Majesty's Railway Inspectorate. The multiple unit operation as far as this country is concerned, is still unique to Metrolink. None of the other networks can do it. GMPT specified it that then they wanted to be able to run double units. So autocouplers were fitted to the trams and indeed to the newer M5000s. One thing I missed, I should have said there, is that once we'd done the testing, we had to, before we could open, we had to operate each section for 6 weeks in trial running. So it was a full service, but without passengers. And during those 6 weeks, various emergency exercises were undertaken alongside the emergency services. One memorable one in Heaton Park Tunnel, where, well, really, the purpose of holding tests was proved because things started to go wrong. And actually, unfortunately, 2 of the victim, I don't know what you call them when you have volunteer victims in these things, 2 of them actually had to be taken to hospital with exposure because they'd been sat in the tunnel in the middle of the winter for 4 hours in the cold. And unfortunately, they were suffering from the effects of the cold. The main problem was it was found that the batteries didn't hold the lighting on long enough to make the rescues, so modifications were made. At Queen's Road, on the site of Cheetham Hill carriage sidings, just behind Cheetham Hill Road, Cheetham Hill signal box, land was made available. A landfill site was made available by Manchester City Council for the construction of the depot and the operations and maintenance centre. There was the workshop was built to service the 26 trams, and the yard was laid out to stable 26 trams. There was a combined office block and control facility. This photograph shows the control room in its very early days, with CCTV, signalling monitors on the desk in front of the 2 guys that you can see in front of the TV screens, and overview. In place of the old power signal box diagram, there were 4 monitors that showed the whole network. It was crude, but it did the job. The signalling where there were controlled areas was British Rail standard solid state interlocking for the junctions, provided by GEC. The maintenance workshop, as I say, it was equipped to be able to handle all heavy repairs as well as day-to-day maintenance. So you could, well, full body lift, as you can see on the jacks there. There was equipment such as an underfloor wheel lathe for reprofiling wheel sets without having to remove the bogies, which is nowadays commonplace, but wasn't quite so commonplace in those days. What else could we do? Oh, we could retire wheel sets. The wheels on them are resilient. They have rubber blocks between the tyre and the wheel centre. So we could retire a full set of wheels. The wheel lathe did prove to be quite an asset, and third-party work was taken on. There's 2 examples. In the distance on the right-hand picture, you can probably see a rather ancient-looking tram. That's from Heaton Park. That had been in for that photograph was taken on the open day that they held in 1994. And the tram, they asked for an old tram, and in return, we got the tyres turned on it. The one on the left at the bottom is an ex-Berlin tram that the National Tramway Museum at Christchurch have as a disability tram, because it's got a wheelchair lift on it. That one came in about 2 years ago for tyre turning because it needed specialist work on it. Interestingly, the guy who's pointing at it was from East Berlin and remembers the tram. He was on one of the European committees setting standards for signalling. Right, the system presentation was supposed to be, it was supposed to follow the branding, if you like, of the aquamarine and the grey. So we had split level platforms in the city because we'd inherited high level railway platforms and the money wasn't available to remodel the stations for low floor trams. So these platforms were profiled so that the level access areas for wheelchair access were high, and the T68 trams had steps that would allow you to board and alight from a low-level platform, which was done really to minimise the impact on the streets. Ticket vending machines were provided for fare collection, and on the platforms there were staff telephone units, passenger help units, passenger emergency call points, which were linked to the CCTV. So when you press the button, the CCTV camera automatically recorded your image and the audio of your call. TVMs were a bit of a problem, and indeed the ticket machines seem to have a history of being problematic. So what else next? Oh yeah, the network then. We opened late. I think it was just over 6 months late. I think we opened in four stages. On April 6, 1992, we ran from Victoria. Started running from Victoria to Bury with a 12-minute service all day. This was followed. Well, I think within the first week of opening of that section, the trams ran through from Victoria to GMEX out of service as part of the trial running. And on April 27th, we started running through the city centre. The bottom left-hand picture is the first tram breaking the barrier at Victoria into the city centre. The tram was specifically chosen actually because 1007 was the last of the first generation trams in Manchester, and the plaque on the front of it was off that tram. 1007, that one, now resides in Trafford Depot awaiting movement to the Heaton Park tramway. It was presented to the museum and will be moving there hopefully before too long. Yeah, so June the 15th, we started running through to Altrincham. The system was opened by Her Majesty the Queen on July the 17th. And finally, the Piccadilly branch opened 3 days later. So that was on a Friday, I think, and we opened to Piccadilly on the morning of the 20th. And that threw up a problem because up to the Piccadilly branch opening, we'd been running trams from from Bury through to Altrincham, and for the first time we'd linked the north and south of the city. And by that time we were running a 10-minute service during the off-peak and a 5-minute interval service during the peak. When we opened to Piccadilly, the trams ran every 10 minutes direct Bury to Altrincham, and every 10 minutes Bury to Altrincham via Piccadilly in the peak. In the off-peak, the direct trams were taken off, so the direct link across the city disappeared, and there was a lot of public reaction to that, understandably. And in the end, the deal was done whereby the service frequencies were dropped to 12 and 6 minutes, but the direct service would run all day. So we ran that network from 1992 to 1997, and at that point GMPTE awarded a new concession to an outfit called Alltram. This was a private finance initiative to build a new line from Cornbrook via Salford Quays to Eccles, and there were to be 11 new stops added to the network. Well, again, most people are aware of it, but that's shown on the map there. So the GMML concession terminated early with the new competition awarded. The phase 2 line, Alltram, was a consortium consisting of Langs for civil engineering and Salvo, the Italian company, who were going to do all the electrical and vehicle signalling and substation work. Serco, service industry company, who were going to do the operations, and the 3i Investment Bank, who were funding it. So Langs was responsible for civils and track. Well, it's there in words. To operate this network, this part of the network, 6 new trams were ordered. Surprise, surprise, seeing as Ansaldo were part of the bidding group. They were T68s again, only an updated version of them. This time, the T68As had an AC traction system with AC traction motors, whereas the T68s were DC. Things have moved on a bit in the regulations that govern the running of trams on the street, because this line introduced the first true street running. The couplers could no longer be exposed. The bogies could no longer be exposed. The braking system had to be different because the emergency braking system was revised so that the drivers could release it before they stopped. The T68s, if there's emergency brake application, the tram had to stop before the driver could release it. A new control, the control room was updated and enhanced. New equipment was provided. The same room, but far more CCTV, a more traditional railway style overview screen, CCTV monitors, and traction control screens and signalling screens were provided. So it was a totally new set of equipment. Again, we opened in stages. Cornbrook to Broadway opened on December 6, 1999. The cynic in me says it was because Tony Blair wanted a good news story and he was in Manchester. He wanted to be able to do something nice, so he wanted to open the tramway because it really pushed us to be ready for that. Broadway to Eccles then opened in July 2000. And as I say, this line introduced the first true shared street running to Metrolink. And it required modified trams, covered retractable couplers, skirted bogies, and a revised braking system. To ensure, this was where cost cutting came in. The PTE specification for the service foresaw 7 trams from Eccles into the city centre in the morning peak. The journey times were going to be such that that would need 7 trams, but they only ordered 6. That's Ultram, only ordered 6. And there was a nice scheme, and some may remember a scissors crossover outside Piccadilly Station on London Road. The idea of that was it would save a tram off the Bury Altrincham circuit to service the Eccles line. It never worked. And in the end, 3 of the T68s were modified to match the T68As in terms of braking systems and couplers and the like. By this time, we'd run phase 1 with 26 trams, turning 23 out every day. And to be honest, we were lucky if we could get 22 out. What with failures and collision damage, it was really stretching the technicians to turn out sufficient trams. Once the Eccles line opened, the peak requirement was 29 out of 32, which was even more tight, really, particularly as the T68As were less reliable than the T68s. So Serco started looking around for second-hand trams, and a number of systems were modernising their fleets at that time. So we looked at Hanover. The consulting arm of the Hanover Tramway had been involved in Metrolink Phase 1, and their TW6000 tram was a very close match for the Metrolink system. It was capable of low floor and high floor operation. It had step boxes, which would have been a good match. The Born Stadtbahn B, which is a fairly standard German tram, was another one we looked at, and the San Francisco Boeing tram. The Hanover ones were just, I don't suppose Metrolink acted quickly enough because they found homes elsewhere very quickly. The Bonn Stadtbahn had an interesting, I think the best description is the guy who was acting as agent to sell them was a bit of a Del Boy character, and he couldn't prove who they belonged to. So in the end, we had to turn our backs on those because it just wasn't sure who was selling it on behalf of. The San Francisco one got the furthest, and in fact, 2 came across to the UK. One went to Derby, to Serco Rail Test at Derby, and the other one actually made it as far as Eccles, behind the diesel loco, after which we decided it wasn't suitable for Metrolink's track, so it died to death. And in the end, Manchester had to wait for another 7 years before any more new trams arrived. Many people will be aware that JMPTE had an ambition for a much bigger network, and they created a project known as the Big Bang Metrolink 2000, which would have added lines out to Rochdale via Oldham. Well, we've got Eccles to the Lowry Centre, a branch from the Eccles line, Dumplington to the Trafford Centre, East Didsbury along the old South Manchester Midland Railway line, the airport, oh, sorry, beg your pardon. Right, yeah, the airport through a loop line, and Ashton via Droylsden. It's interesting to see how far that lot got, actually. However, so the project was costed and went to the government for authorisation. It was looking quite good, actually. But in 2004, it was formally rejected, along with schemes in Liverpool and Leeds. A privately funded short extension to Media City in place of the Lowry Centre did go ahead, opening in 2010. The timing of the announcement of the rejection of the project was very, very bad, because it was about the time that Docklands Light Railway got the funding to enable it to be extended in line with the proposal for the Olympics in London. And there was an awful lot of bad press about that. Justifiably, I personally believe, I must admit. Not to be outdone, though, GMPTE still looked for ways that they might be able to fund extensions, and as a lot of people will remember, a congestion charge plan was put forward. Putting it out to a referendum, I think the result was, well, it was a no-brainer, really. Nobody was going to say, yes, I'll pay to use my car. But a multi-stage plan was put together in the background, and phase 3 did start to appear. It was divided into 2 batches of work, what was called the accelerated works, which would see a line from Trafford Bar to Chorlton, St Werburgh's Road, near where Chorlton Junction used to be. The East Manchester line would get built as far as Droylsden, and the Oldham Rochdale loop would be converted using the existing railway tunnel route through Oldham. The group that had constructed the Media City branch were awarded the contract for the accelerated works. This was the MPT consortium, we'll define shortly. Working in the background, they also then brought forward what were called the non-accelerated works, which extended the South Manchester line to East Didsbury, the East Manchester line to Ashton, and the 2 town centre sections in Oldham and Rochdale, which allowed the Oldham tunnels to be abandoned. And finally, St Werburgh's Road to Manchester Airport via the Wythenshawe Centre, the other side, the western side of the loop, was dropped for the time being. 2 additional schemes came forward whilst the accelerated works were being constructed. GMPTE, well, by that time, Transport for Greater Manchester realised that the city centre just wouldn't be able to cope with the services, the phase 1 city centre section. So they put forward a line initially that would have gone through Albert Square and then down Cross Street to Victoria through Exchange Square. That was eventually dropped and the line was modified to run through St Peter's Square. That opened in 2 stages in December 2015 and February 2017. And the Trafford Park line, which was what had formerly been the Dumplington line. Now this slide says it was due to open in early 2020. It did actually open in March 2020. So they were all built by the MPT consortium. So they worked for nearly 12 years continuously on the network. I thought I'd put it in there. The MPT consortium was made up of Lang O'Rourke, who were the civil engineering part of the team, Volker Rail, who did specialist track work, and they didn't do the overhead line. They did all the track work. And Tallies, who had two separate contracts. Tallies had a contract for all the electrical work, substations, on-stop services, and they also had a separate contract outside of MPT to convert the system to line of sight operation. And that's still not complete. There's still a short section to do. They're still working on Brooklands to Timperley siding. The tram fleet for the extended network was obviously going to have to be expanded. The expansion plans envisaged that the T68 and 68A fleets would undergo a midlife refurbishment, and a new procurement exercise would be placed for new trams for expansion. In the end, it was a bit of there wasn't much choice, because they only went out for an initial batch of 8 trams for service expansion on the Altrincham and Bury lines. And Bombardier came up with an off-the-shelf tram, which was the Cologne K5000, slightly modified for Manchester conditions. It became the M5000, and the 8 trams were ordered for service expansion. Quickly followed by another order for 4, funded by the developer of Media City. So they were privately funded for that branch. And the fleet has continued. I have to learn to be a bit more careful. The fleet has continued to expand, and as Zane said earlier, there's a second of the final batch is due to arrive tomorrow. It'll be on the road now. The T68 refurbishment project, actually, in the end, it was abandoned. The photographs at the bottom show the poor state of the underframes of those vehicles, and there were specially steel rolling sections that couldn't be bought anywhere. Nobody was prepared to roll the steel for repairing the sole bars. So in the end, the decision was taken. They were just beyond redemption, really. It went through 2 stages. They initially intended replacing the 12 worst vehicles. In the end, they decided to bin the lot and replace them all with M5000s. So the 8 that Bombardier bid for has now become 147, which and the price has stayed pretty constant. I mean, I say that it's varied with each batch, obviously with exchange rates and things, but the prices, it's stayed fairly constant throughout the purchasing. And obviously got the benefit of a standard fleet. A new depot was built at Trafford behind what is Old Trafford Stop. A new depot and a new control centre and an office development was built there. So the new facility has stabling space for 94 trams. That's currently being expanded. And Queen's Road can manage about 40, although that's very, 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 very tight. And currently, both depots are being expanded to cope with the 147 vehicle fleet. At the moment, the way things work is Trafford is mainly a running shed, if you like. It does day-to-day inspections and tram prep. Queen's Road does most of the heavy work, the heavy overhaul work. So body lifts, bogie changes, things like that. Accident repairs are generally done at Queen's Road. Both depots have underfloor wheel lathes. Trafford's got a very, very modern computer-controlled one. Queen's Road is a bit more traditional in that Tracy's templates. I am told the Queen's Road one is far more flexible in operation than the one at Trafford. So any special work gets done at Queen's Road. The T68 finally bowed out in 2014 with a special. There was a special farewell tour of the Phase 1 and Phase 2 network on April 30th. They were never gauged for the other lines, although T68 did run as far as St Werburgh's Road, and I believe one actually reached East Didsbury for some tests with the Network Rail, but they were never gauged for passenger operation. Excuse me. 1007, as I say, has been handed over for preservation at Heaton Park eventually. And 1016 actually managed 2 million, well, not far off 2,700,000 kilometres in its life. They were actually used far more intensively than was ever envisaged because of the change in service pattern. T68As were never very successful. They were subject in the summer, they suffered badly with overheating. And when they were on Eccles line duties, it wasn't uncommon for one to have to spend a complete round trip in the sidings at Piccadilly and be replaced by another tram to allow it to cool down. But one of the problems with them was the line speeds are so slow on the Eccles line that they never really got a chance for any airflow around them. And the final two ended up on the Bury line, where actually they became the most reliable trams in the fleet because of the higher speeds. That was taken on their last day in service. And other than 1007, 1023 and 4 more that are at Long Marston, the rest have been cut up. Right, extending the network. As I mentioned, the TfGM let out a contract to convert the whole line, the whole system, from block signalling to, because the Bury and Altrincham lines were block signalled originally, to aspect block signalling. ORR weren't that happy at the mix of signalling systems from a driver's perspective, and they put pressure on to get the lines converted. TfGM were, to be honest, enthusiastic because it would increase the capacity. So as things stand, I think this slide may be slightly out of date. Oh no, it's not, I've updated it. The last bit now is Brooklands to Altrincham, which still retains its block signalling. There doesn't appear to be a plan for Timperley to Altrincham at the moment to convert because of its signalled by Network Rail. But I believe equipment is now being installed at Timperley to do the Timperley siding area. Cornbrook is a bit of a problem there. Cornbrook to St Peter's Square is a little bit of a problem area. It's a bottleneck, and line of sight operation has definitely opened that up. The theoretical capacity of that is 50 trams an hour in each direction. I don't think that's ever been proved, but that's the calculations that the signalling engineers did. Certainly, that the intention of that photograph at the bottom was to show that you can close trams up in the tram stops now, which you couldn't do with block signalling. The second tram would have had to wait on the Eccles line before being allowed. This one would have had to be halfway to GMEX before it could move forward. So that bottleneck has been eased. But you're right. So Second City Crossing was built, obviously, really it was part of the airport line contract, because to operate the airport line trams across the city would require more capacity. Now that might sound silly because the airport trams actually use the original alignment, but during this development of the airport line, they realised they wouldn't be able to operate everything that they wanted to, and that's why at the time the airport line only opened as far as Cornbrook, because 2CC was under development at the time. It resulted in a massive redevelopment of St Peter's Square and Victoria, where the two routes join at either end of the corridor. As of 2019, and obviously things have changed now, the Cornbrook to St Peter's Square corridor was apparently identified as the busiest light rail corridor in the world, the maximum throughput of 35 trams an hour. That would have gone up to, well, that would have gone up to 40 when the Trafford Park line opened. But sadly, certain viruses intervened to stop that happening. So the photographs we see here, we've got a tram gauging run in 2000, I can't remember what year that was now. All I know is it was a Halloween night because there were a lot of revellers in the city centre. But by this time, gauging was being done with trams that were live and able to move under their own power. Computer modelling had shown the profiles of the platforms and all the sighting GPS positions of all the line side infrastructure. So everybody was confident enough to do them under power. One of the features of 2CC is most of the overhead line is fastened to buildings rather than having poles. As you probably remember, Manchester got a lot of criticism for the number of overhead line poles in Piccadilly Gardens on phase 1. Well, most of 2CC, the buildings support the overhead. And St Peter's Square had a comprehensive remodelling, and if you like trams and city life, it can look quite nice in the evening with plenty of trams about. A lot of people may not like it, I know. So the next one was Trafford Park, which was going to run from Pomona on the Eccles line out through Trafford Park. It's known as the Trafford Park line, not the Trafford Centre line. And the original bridges at Pomona for the Eccles line were built with this line in mind, and adding the bridge works was fairly straightforward. And we can see bridge sections being lifted in there whilst the trams carried on running. And the other photograph shows the Trafford Centre. That would have been taken in 2019 on a typical Manchester wet day. So construction started in January 2017 and services planned to commence in late 2020. That was the timescale when the project started. The line was substantially complete by the end of 2019 and test trams had started running by then. There are six new stops at Warside, which is designed to be able to deal with Manchester United matches and concerts at both the cricket ground and the football ground. Imperial War Museum North, Village, which is just on the fringe of what was Trafford Park Village, Parkway, Barton Dock Road and the Trafford Centre. Some of those stops actually had, Barton Dock Road was to be called Event City, but seeing as Event City's closing, that name changed. And the Trafford Centre, well, it opened as the Into Trafford Centre. What it is now, I have no idea. I haven't been down there. Testing started in late 2019 and the line opened on the 22nd of March, 2020, just as COVID lockdown struck. The initial service only operates between the Trafford Centre and Cornbrook. That's because there simply aren't enough trams to operate it through to its eventual terminus, which will be Crumpsall, another cross-city service. And we see the first tram ready to depart from the Trafford Centre at, what would that be, about quarter to 7, I think, on Sunday morning. More staff than passengers, obviously, because of the pandemic. It was a big political decision to open it despite the pandemic, because it was done to provide extra capacity on the public transport into Trafford Park. And it will eventually run to Crumpsall, where a new turnback facility has been produced, and the Crumpsall station remodelled to take that into account. A new facing crossover and a siding, which may get modified if the Middleton line gets built. Line of sight signalling principles, just a bit on this, because it's very different than railway. Trams operate under line of sight as road vehicles. They are classified as a road vehicle, and the construction and use regulations were modified to deal with trams. An LRT signal, such as the white lights you see on that that signal. I don't know whether you can see the cursor that I keep wiggling about. I'm not sure. That signal does not give absolute authority to pass. The driver can pass only if it is safe to do so, and he must drive at speed consistent with his braking distances. So he must drive at a speed where his braking distance is no greater than the distance he can see. All the same as we do it every day in our cars, don't we all? Or do we? But it's different. A railway signal, when a driver sees a green or a double yellow, that tells him it's safe to go. A tram signal doesn't, just like a traffic light doesn't. You have, as the driver, have to make the judgment whether it's safe or not. Tram detection is normally by means of induction loops cut into the road, and different tram networks have different systems. Highway intersections, such as the one we see in the slide, they're controlled by road traffic lights with LRT signals added, and the controllers are standard road traffic signal controllers. Facing points are provided with point indicators, so the tram signal, unlike a railway signal, doesn't give you the route information. The point indicator gives you that, and they are the yellow or orange indicators. Signage is an interesting one, and Metrolink fallen foul of it over the years. Excuse me. Approved highway signage has got to be used. There's a highways signage manual which has to be followed. All signage has to be approved, so it has to be in the catalogue of road signage. The purpose of this slide is just to say how silly it is. This photograph on the left shows a double unit on test during 1992, early 92, and we see no entry signs on Moseley Street, which say no entry except buses. Technically, that means that every time a tram went up Moseley Street towards Piccadilly Gardens, the tram driver was breaking the law, because he's not a bus, he's a tram. We couldn't put no entry except trams and buses, or even no entry except trams, because that sign was not approved in the highways manual. So, in certain places, they adopted these blue signs which say tram only. Trouble with those is they're not mandatory. They're approved, but they're not mandatory. So I think it's well known how many cars have ended up on the tram tracks and stopped the service. So this problem of car incursion, the blue advisory tram signage began to be replaced by red mandatory no entry except tram signs, which were, if you just went and put them up, they were illegal. Each sign, such as these that we see on the bottom photograph, each individual sign had to be approved by the Minister of Transport. He had to sign them all off, and each one had to be applied for by the local authority, the highway authority, because those signs still don't exist in the catalogue. We've only had trams running 25 years, but they're still not in the book. Bit on the trams, the old T68s and T68As, with two-section articulated vehicle. We weighed approximately 48 tonnes, maximum speed 50 miles an hour or 80 kph, 750 volt DC. The T68s had 4 DC traction motors, the T68As 4 AC traction motors. They had blended air brake and dynamic brake, dynamic braking being electric braking, where the motors are used as generators. Electromagnetic track brakes, they were full regen braking capability. Should the overhead line not be receptive, in other words, there's no load to accept that power that's been regenerated, it's dissipated through rheostats on the roof. They had an air release spring parking brake, which is a sort of an automotive type brake, so the air holds the brake off. They had self-leveling air suspension, multiple unit maximum of 3 units, but you can only run 2 in the street. Capacity of 82 seats, total of 200 passengers, or if you want to really crush load them, 270. The reliability worked out about 10,000 kilometres per failure. It was a lot less than that in reality. That was the quoted figure. Oops, again, sorry about that. The M5000 comes in at only 39 tonnes. The T68s were actually about 3 tonnes overweight when they were delivered, but the railway bogies accounted for that. The M5000 has a tare weight of about 39 tonnes, maximum speed 50 miles an hour again, 750 volt DC, 4 AC traction motors, dynamic braking with electromagnetic track brakes. There is no air on these trams at all. It's electric brake to a stand. Regenerating braking, again, like the T68s. Hydraulic spring parking brake in place of the air brake. Multiple unit operation, again, a maximum of 3 units, but again, we can still only operate 2 in the streets because the consists would be too long. Seating capacity varies between batches, actually. This says 78. I think the later ones had 8 additional seats in them. And a total capacity of about 188. That actually, again, there is a crush loading capacity way over that. The reliability is about 3 times that of the T68 fleet. But they're a tried and tested unit because Cologne have been operating them for quite some time. Power feeding, well, phase 1 was pretty standard third rail style substation at each end of each section, feeding both ways into the centre, with separate breakers for the inbound and outbound lines. There were monitoring facilities between the 2 substations, so the circuit breaker came out at, in the case of this slide, came out at Bowker Vale on the inbound. The one feeding the same section at Prestwich will be tripped out as well, so that you're not feeding into a fault. The phase 3 lines actually don't separate the inbound and outbound lines. They feed with 2 breakers at each substation instead of 4, which is more normal tramway practice. These are screenshots off the system. And the right-hand one is what the controller in the control room sees and uses to control the breakers in the sub. So each substation is rated at 1.2 megawatt, and the supply varies from the distribution network operator. Some are 6.6 kV, some are 11, depending on what's in the area. There's full control of the substations from the control room through a SCADA system. Overhead line, we have traditional railway style catenary on the higher speed former heavy rail lines, as we can see at what was Woodlands Road tram stop on the Bury line there. Traditional tramway style trolley wire systems, single wire trolley wire systems on the street side. Eccles line's a bit different. Eccles line in the city centre actually have twin contact wires, just to get enough cross section up in the air, whereas the phase 3 system uses single wire and trackside parallel feeder cables. The wires are divided up into sections with section insulators, which basically have these will be a resin composite section in them, and as the tram passes through them, it briefly short circuits so that you don't get a flash as it passes from one section to another. Signalling and control, I've already mentioned that we have these white dot signals. These are LRT signals. They are specifically designed so that they don't confuse other road users. As a railway signalling and telecoms engineer, that signal on the left is a mess. How the drivers are expected to read that, there's just too much information there. A point indicator, a tram signal and a road traffic signal side by side on one pole is not good, but that's what the road traffic signalling engineers specified. I mentioned tram induction loops, and this is a tram induction loop. That's at Newton Heath, I think. Yeah, so that's the way the tram communicates with the control system. Metrolink's trams, as they pass over a loop, they send information about. There's a complete handshake between them. The loop tells the tram where it is. The tram tells the signalling system where it's going and what its timetable journey is. And from that, the signalling route setting is done. There is no route setting in the control room. It's all got to be done out on the ground. The idea of that is it stops points moving when people are walking across them in the streets. So the tram is in theory a deterrent to the pedestrian who might get his foot trapped in the point blades as they move. Points are operated via the embedded detection loop on the photograph at the bottom. They're then locked as the tram approaches them via a track circuit and a mass detector. One of the problems with tramway point work is it's all bonded together for the return currents. So you can't normally take the track circuit through the points. So you use a mass detector, which just looks for a big lump of steel, basically, and locks the points. And then we have point machines of varying types, either hydraulic, electric, or even sprung points, depending on the function they have to fulfill. These are the sort of screens that the controllers see. This is a signalling screen, which is purely monitoring, so that the controller can see where all the trams are. It's not very clear, this one, I'm afraid. You've got the tram descriptions that move along the route in colours, a bit faint on there. That's in the city centre, that stretch. So you can monitor where all the trams are. The lower screen is actually one of the traction power screens showing all the substations on a particular stretch of track. And the controllers then can call up a specific substation and operate all the circuit breakers in there. Track forms, we've got 4 basic types. Traditional sleeper track, which use twin block concrete sleepers. They are 2 concrete blocks linked by a steel bar. They're lighter and they are perfectly suitable for tramway operation. We've got concrete slab track. In other words, it's flat bottom track laid in the same fashion as the ballasted track. But instead of on ballast, the sleepers are then embedded in concrete. The track's levelled and then mass concrete poured around them. It keeps the track in position. It's fairly simple to maintain. It's expensive in the first cost though. We then have slab track where the rail fixings are bolted direct into the concrete slab. These tend to be in areas where you've got noise and vibration problems, and this is on Ashton Moss. And there's an hotel on the corner, on the inside of the corner here. So this is specifically designed to reduce noise and vibration. And the other is the traditional tramway embedded groove rail, where it's laid on a concrete slab and then embedded in concrete. Insulated, the rail is insulated as well. There's an insulating boot goes around the rail. And really that's where we are. As I say, the system, there are proposals for lines, for more lines. Just how the COVID pandemic will, I don't know what effect that will have. I've no idea. It's money is going to be very, very tight for a considerable length of time. But I believe lines to Middleton and Staley Bridge are fairly well up the list. Be interesting to see what happens in the next few years.